Alright guys, this is going to be our range video, one of the most important topics of your pre-calc career aside with domain. So let's get right into it. What is range? So range is all of the possible y values that you could get out of your function. It's basically what are all the possible outputs, all the y values that come onto my graph, okay? So let's start with a simple example. Let's start with the line. Okay, this in particular is the line y equals x, okay? You'll see that the height of the graph, the height in the negative direction and the height in the positive direction, consistently go on and on and on and on until forever. Therefore, we can say that since the graph extends downward forever and upward forever, that our range encompasses all numbers from negative infinity to infinity. Now, it's very important here that when you are using infinities in your range, you always, always, always give them a soft bracket, okay, on both cases. Now, I explained this in the domain video as well, but the hard bracket is something that you use when your range includes a certain value, and your soft bracket is something you use when your range does not include a certain value. So if I go on my range 4 to 5, this notation would tell me that my range is between 4 and 5, but it includes 4 and doesn't include 5. So moving on from there, let's look at our functions that use exponents. F of x equals x to the a, where a is the exponent, okay? So if a is even, then we're going to need to do some range calculations. If a is odd, then your range is going to be negative infinity to positive infinity. And you know that right off the bat. So let's do an example of that. An example of x to an odd power, x to the 1, you just saw was a straight line. But in favor of doing more examples, let's consider x to the 3. X to the 3 looks a little something like this. And you'll see that the range goes up and down to infinity forever. Okay, so with that being said, let's consider the example where we actually need to do some work, which is when x is an even power. Okay, that would be a parabola. Let's consider first y equals x squared. The range of that, as we can see, is 0 up until positive infinity. But now our question is, does it include 0 or does it exclude 0? 0 equals x squared. Well, there is an x I can plug in. I can plug in 0 in order to get out 0. So therefore, my range does indeed include 0. So I'm going to write my range here as 0 inclusive up until positive infinity. Okay, that's going to be my range. Now, let's consider the example of y equals negative x squared. And always when we are evaluating range, it is very, very useful to be able to draw the graph. It is very, very useful to be able to have the shapes of the graphs memorized so you are able to draw them if you need to. So let's look at y equals negative x squared. That is an upside down parabola. Okay? So that is going to have a range of negative infinity up to and including 0, okay? Because we extend all the way downward. So if I gave you a parabola y equals negative x squared plus 3, that means that our plus 3 is going to put us 3 units higher on the graph. So our upside down negative x squared parabola is going to look like this. Therefore, our range, since we're extending all the way down to negative infinity, is going to be negative infinity up to and including positive 3. Okay? Now, there are more complex forms of parabolas that we can see. For example, let's look at y equals x squared minus 4x plus 5. So this is a bit more challenging to think about because it's not immediately obvious what the graph looks like if we try to put it on the coordinate plane. So that's where a very useful equation comes in hand. The equation for the vertex of a parabola. The equation for a vertex is x equals negative b over 2a, okay? Which means the x-coordinate at which your vertex occurs is negative b over 2a, where the coefficient of x squared is a, coefficient of x is b, and the coefficient right here is c. So b is negative 4. The negative of that is just regular 4 divided by 2a. A is 1, 2a is 2. Therefore, the x-coordinate is 2. Okay? So my vertex occurs at x equals 2. So now what I do when I find my vertex is I take that x value and I plug it back into my function. So y equals 2 squared minus 4 times 2 plus 5 equals 4 minus 8 plus 5 equals positive 1. So therefore the ordered pair representing my vertex is going to be 2, 1. So now that I know where my vertex is, I can draw my parabola. 1, 2, 1. So my vertex is going to be right here, and I'm noticing it's a right side up parabola, so it's going to look like this. Okay, now I see that the lowest value achieved by my parabola is going to be the 1. So therefore, my range is going to be 1 inclusive up until infinity. That infinity is going to be with a soft bracket. They will take points off for that. Another important function to consider is the function y equals rad x. Okay, if we draw a graph of y equals rad x, it's going to look like this. Okay, now something that's important to consider is if I have y equals rad of negative x, the function is going to get reflected, and in turn it will start to look like this. Excuse my shaky hand. If instead I did not have y equals rad negative x, but instead I had y equals negative rad x, that would mean that the function would look like this. And if I had both, negative rad negative x, it would look like this. So what we need to do here is when we are given an example of y equals rad x, we need to determine which way our function is going. Okay? So first things first, I'm going to show you the default case where we're just looking at y equals rad x, and we're going to worry about this in just a moment. Okay? When we graph it like this, we notice that our range is everything from 0 inclusive all the way up to infinity exclusive. So for example, if I were to do y equals rad x plus 3, then that would raise my function up by 3. And instead, it would look like this, where we start right here, and instead my range is everything including 3 up until infinity. This is a soft bracket to make it abundantly clear. So now let's work on an example. Y equals negative rad negative x plus 3. Now this is a pretty hard example, so I'm going to challenge all of you to do it on your own, and then you're going to come back to me to walk you through it. Okay? So if you're unclear on transformations and how they work, I highly suggest you check out the transformations video. It's going to be very helpful here. But we are going to consider how this is modified. So first of all, we're going to be raised 3 up. Okay, so we're going to start up here at 3. Okay, and we're also going to be moved 3 to the left. So that's going to place our origin point of the function right here. This is going to be a negative x, so it's going to be going in this direction. And the negative is also outside the radical, so we're going to be going down in this direction. Therefore, the shape of our graph is going to look like this. So we can see now here that the maximum value we obtain is 3, and the minimum value we obtain is negative infinity. So we're going to write our range as negative infinity up to and including positive 3. And there you go, guys. If you ever need extra help from this, just join the Discord server, and aside from that, enjoy life.